Activation energy. Here's a mountain climbing race. There are two racers, Kevin, a boy who drinks an energy drink, and Tom, a boy who doesn't drink anything. Let's start the race. We see that Kevin is running super fast and will reach first, while Tom is running with his maximum capacity. The race is finished, and Kevin is the winner. This is a simulator example to the chemical reaction rate in the activation energy. We link the reactant with two racers and the catalyst with an energy drink. As we see here, the reactant without catalyst has a high activation energy and will take a lot of time to reach the activated complex to produce the products, while the reactant with catalyst has a small activation energy and will take a shorter time to reach the activated complex to produce the products. What is activation energy? Many chemical reactions and almost all biochemical reactions do not occur spontaneously and must have an initial input of energy called the activation energy to get started. A and B must collide with sufficient energy to break chemical bonds. Once chemical bonds are broken, new ones are formed of its products. So, from what we explained, activation energy is the least amount of energy required to activate atoms or molecules to state in which they can undergo chemical reactions. The activation energy of a reaction is measured in joule or kilojoule per mole or kilocalories per mole. What factors affect activation energy? Catalyst. How does catalyst affect it? Temperature. What is the relationship between activation energy and temperature? Presence or absence of catalyst. Catalysts are substances that increase reaction rate by lowering the activation energy needed for the reaction to occur. Catalysts increase the rate of reaction. Catalysts are not consumed by the reaction. Catalysts do not change the equilibrium constant of the reaction. Temperature. What is the relationship between activation energy and temperature? The rate of reaction depends on the temperature. As the temperature increases, the molecule move faster and collide more frequently. The molecule also carry more kinetic energy. Thus, the proportion of collision that can overcome the activation energy for the reaction increases with temperature. We can explain the dependence of chemical reaction to temperature by Arrhenius equation. Here we have the Arrhenius equation that demonstrates the effect of temperature on the activation energy. The Arrhenius equation is based on the collision theory. Here's an example of Arrhenius equation. In this equation, we need to find the value of the activation energy. So we modify the equation to find the activation energy value, which equals the slope on R, gas constant, I, and its unit gonna be joule per mole. Activating endothermic and exothermic reactions. The red arrow and blue arrow represent the exothermic and endothermic energy changes. The purple arrow represents the activation energy and measured on the left side of the hump.